Trigonometry, Chapter 5, Trigonometric Identities, Section 2, Verifying Trigonometric Identities, Video 9, Verifying an Identity, Example 8. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. This is the final video in the series. Oops. All right, let's verify this identity. The left side is 1 plus cosine x over 1 minus cosine x minus 1 minus cosine x over 1 plus cosine x equals 4 cotangent x cosecant x. Needless to say, we're going to start with the left side of the identity and see if we can end up on the right side. I did go ahead and copy this into a PDF so that I can have more space to scroll and write. All right, so what do you think we should do on the left side? Now, some of you are thinking, I'll just miss this one. But honestly, it's ones like this that really separate those of you who think you can do algebra and trig from those of you who are actually capable of it. And I believe all of you are capable of it. You just need to not be scared, have a plan, and execute it. So let's look a little bit more closely on the left side, the difference of the two fractions. Because it's all cosines and none of them are squared, I don't see any trig identities that we can capitalize on. So if our first move isn't trigonometric, it's going to be algebraic. Now, algebraically, this is the difference of two fractions. And so algebraically, we would want to get a common denominator. So let's start by setting up a common denominator for both of these. Here's the first fraction. And remember, to get the common denominator, all we have to do is multiply both sides of the fraction by the denominator of the other fraction. So we're going to multiply the first fraction by 1 plus cosine x over 1 plus cosine x. And for the second fraction, let me get it written. We're going to multiply both sides of it by the denominator of the second fraction, which was 1 minus cosine x. And again, like in a previous example, you might be thinking, oh, these are conjugates. And you're right, they are. But the conjugates are not what drove this. What drove this is the fact that we are subtracting two fractions. And I almost sent this problem into a tailspin because I put a plus in the middle. It should have been a minus. Catastrophe averted. We would have had to backtrack, do damage control, and then figure out how to get to the correct destination. All right, so let's see what happens as a consequence of this algebraic move. The common denominator is going to be the product of 1 minus cosine and 1 plus cosine, which is 1 minus cosine squared of x. That's the difference of squares. But on the numerator, we get 1 plus cosine of x squared minus 1 minus cosine of x squared. And I have a dirty trick up my sleeve. The denominator is going to become sine squared. That part is going to be just a Pythagorean identity. So this is the consequence of a Pythagorean identity. But what are we going to do on the top? Now, the casual algebra student, math student on the top, what they would do is they would write both parentheses, FOIL everything out, and then be careful to distribute the negative across the second result. But if you have a little bit more global perspective of the numerator, you'll notice that it is a difference of squares. Granted, the things being squared are big and chunky, but it is 1 plus cosine x times squared minus 1 minus cosine of x squared. Now, why is this beneficial? Well, remember how a difference of squares works, and I'm going to go back to the slideshow and go all the way back to the very beginning where we reviewed the the algebra moves. Almost there. Okay, that's multiplying, which is just factoring backwards. But we did okay, where was it first brought up? There it is. If you look at this, and get a highlighter going here. If you look at this as a factoring move, it says when you have a difference of things squared, the first factor is the difference of the things, and the second factor is the sum of the things. Well, I can use that here. How? Very carefully. I'm going to set up two parentheses, one with the plus, one with the minus. And what's going to go into the two parentheses are the sum and difference of the yellow and pink. So although I could FOIL out both of the squared parentheses right here, I'm choosing not to because I'm taking advantage of the fact that the numerator is a difference of squares. Now, if this is not an intuitive move to you, I completely understand, but it's this level of thinking, deeper level of thinking, that will elevate you as a mathematics student. So the first yellow thing, the thing in yellow was 1 plus cosine of x. Hope I have enough room to write this. 1 plus cosine of x. And let me zoom in on this. There we go. And the thing in pink was 1 minus cosine of x. So it's a larger scale difference of squares. Now, here's where you got to proceed with caution. The one that I just wrote here in the second pink box is part of a subtraction problem, which means that minus applies to all of that. So let's clean this up and see what happens. In the first parentheses, the cosines cancel, and we have 1 plus 1 is 2. That's good, because didn't we have a 2 in our final destination? No, we had a 4. Well, at least we got a 2. What happens in the second parentheses right here? Well, when we distribute the negative, well, let's just play it out piece by piece. 1 minus 1 cancels, and cosine minus negative cosine, cosine minus negative cosine. The minus minus becomes a plus. We get 2 cosine of x. And there's the other 2, and we're about to get the 4. 2 times 2 is 4. But let's stay focused on our goal. Our goal is to get a 4, a cotangent, and a cosecant. If we split up our trig functions into two fractions, give each one a sign, a sign, because we're unmultiplying, so it's not a common denominator issue. And then take the cosine that's on the top and put it on top of the first one, and a 1 on top of the second one. Then cosine over sine is cotangent. 1 over sine is cosecant. If we cite our moves, this was a quotient identity and a reciprocal identity. And correct me if I'm wrong. Is that the only trig move we did? Oh, no, we used a Pythagorean identity to change the denominator to sine squared. So it's sort of a hot mess, and part of that is because I'm writing with my finger in PDF. But when you are trying to prove an identity, you can't be scared to take some algebraic leaps of faith. Adding fractions or subtracting fractions by getting a common denominator. I will admit that the move that I use with the difference of squares, where everything is highlighted in all the colors, is not a standard move, but it sure is a nifty move, because the other option would have been to FOIL everything out, put everything together, hope for the best. And trust me, if you do it correctly, it should get you to the same destination. I challenge you, I challenge you to try to pick it up from here, but instead of using the difference of squares, FOIL out the first parentheses, FOIL out the second parentheses, distribute the negative across the second FOIL problem's results, combine like terms, and see if you can get it down to the same goal. There's almost always more than one way to do an identity. And that wraps up this section.